So in this lab, lab 12, or the second one after the first 10, I'm going to take the previous lab, lab 11, and add a DC motor onto it, but I'm going to have the direction and speed controlled by the distance sensor. So the first things to know are that 1, port C, pin 2, well, pin 3, if you're pin 2 if you're counting from 0 like I am, is the PWM. So I will label that as PWM, PWM, and the rest of port C I'm just going to use as my directions for my H-bridge. I'll explain this later. And so now my system code, or system idea I guess, is very simple. I have my sensor and my motor, and I have a very nice switch case. If the sensor has an object within X distance, the motor spins one way, I'll say counterclockwise, and at a speed of, I put it as the value returned from the sensor. Else, spin clockwise at the speed of not the value returned from the sensor. So I basically invert, or one's complement. So if you were able to do lab 11 and get the analog to digital converter working, then this is actually a pretty simple lab. So now then the PWM part of this is where the interesting stuff arises. So my A to D converter, I have 10-bit resolution accuracy. And in my PWM, the duty cycle is also 10 bits. So there's a nice little coincidence there. And so basically the way the PWM works is if I have a signal coming in, the duty cycle is the time high over total time. So if I have a 50% duty cycle, that means that 1, I have 50% of the time is high. Now the motors, if you've seen my previous video on this, are more efficient when they operate at full speed. So the way that we can make them turn at different speeds, of course, is to modulate the duty cycle. So if I have a motor that likes to turn at full speed and I give it a duty cycle of 20%, then 20% of the time it's turning, and the other 20% of the other 80% of the time it is just free spinning. And so that's important to notice. Now in my H-bridge, I actually have a standalone H-bridge set. It's a dual H-bridge, but it takes 3 inputs. It takes a PWM, P, and 2 direction inputs. Now it's important to know what these direction inputs are. So the PWM we just pretty much explained. Now the directions have a couple different meanings. 1, I can have both off. I can have one on, one off. The opposite, so I can have one off and one on. And I can have both on. So this one is coast for mine. This is one direction, depends on how I wire the motor into it. So let's call it counterclockwise just for sake of argument. This one is clockwise, or the opposite direction, and this one is actually the brake function, or it prevents it from turning at all. And so when you go through and you decide to start making this code, all you have to remember is that two of your inputs should follow these direction cases. You should have your PWM set up correctly for the duty cycle, and you need to remember how to get the addressing out of the analog to digital converter into 10 bits, and you need to know how to put that 10 bits into the duty cycle register, which is split between two registers in the PIC 16F. So I'll write that in. .877A, which is the one that we are using for this lab. And that is that.